Okay, in our first video, we are going to work on determining the number of solutions. So part A, how many solutions can there be for a linear quadratic system? So let's talk about this. What is a linear quadratic system? You guys have solved linear systems. For example, let's say you had 2x plus y equals 10. X plus 7y equals 21. I'm just making stuff up. That's a system of equations, and these are two linear equations because we have an x to the first power and an x to the first power. What you're going to see in this lesson is a system comprised of a linear function and a quadratic function. So here's our first example. Here's our system. Y equals x squared. There's the quadratic. Y equals 2x. That's an x to the first power. There's the linear. So that's how this is going to be a little bit different than what you guys have seen before. So how many real solutions? Real solutions means we're not going to bring in I, our imaginary number. Does the system have? One way to figure this out is by graphing. We are going to graph the first equation, graph the second equation, and find those points of intersection. So y equals x squared. We've been graphing these since last chapter. There have been no transformations, so I know that the vertex, well, it's a little bit bigger, vertex is at the origin. Our a value is 1, and it's opening up, so our pattern of points is 1, 3, 5. So up 1 to the right one, up 3 to the right one, and up 5 to the right one is just off our graph. Let's mirror those points on the other side, and we can draw in this parabola. Oh, helps if I put it on the pen feature. There we go. There's that side, and there's that side. Okay, so now let's graph the equation y equals 2x. This is slope-intercept form, y equals 2x. What we're missing is that y-intercept on the end, so plus 0. So when we graph this one, we're going to start at the y-intercept of 0, and we're going to do a slope of 2, so up 2 to the right 1, up 2 to the right 1. So already I can tell that this point right here is on both equations, both functions. This point right here is on both functions. But I'll keep doing my slope points, up to the right 1, up to the right 1. Let's backtrack from the origin down 2 to the left 1, and we can draw in this line. Well, that wasn't super straight, but how many real solutions does the system have? Your solutions are the points of intersection. So we can see that we are intersecting right here. That ordered pair is 0, 0, and we can see that we are intersecting right there. That ordered pair is 2, 4. We are going to have our solutions be ordered pairs because our equations have x's and y's. So we want to have an x and a y as part of our solution. So this equation has two real solutions because the linear function, the line, crossed the parabola, the quadratic, in two spots. Okay, let's try another one. Oh, I guess it's kind of the same one. It says, how does modifying the linear function in this system, so we're modifying the linear function, we're adding in a y-intercept, how does that affect the number of solutions? So let's do that graph again real quick. Actually, I'm going to just graph the parabola because then I want to talk about how our linear function could change. So here's my pattern of points going up 1, up 3, up 5. Okay, I'm hoping that this is going to work. Our line that we drew, I'm just going to draw the line. I'm going to try to hit the points I know it goes through. Goes through this point, goes through this point, All right, so there's the line. So what they're asking us is if we take that linear equation, y equals 2x, and we change the y-intercept, how does that change our number of solutions? Right now, we have two solutions because our line is intersecting the parabola in two spots. If we move that line around, we can see that the number of solutions will change. So, or it could stay the same. So if I move the line up, anywhere I move this line, it's still going to cross the parabola in two spots, okay? But as I move the line down, we've got two intersection points, but right there, when our y-intercept is at a -1, now all of a sudden we have just one point of intersection. So if our b value is greater than that -1, so that's when I move the line up, we have two solutions. It hit the parabola in two spots. When the y-intercept is equal to -1, where I have it right now, it's hitting the parabola in one spot, so there is one solution. And what happens if I move that parabola down? When we move the parabola down, we can see that we are no longer crossing when we move the line down, we are no longer crossing the parabola. So here my y-intercept is at a -1. I'm going to move down so the y-intercept, that b value is -2. I have no intersection points. My b value is -3, no intersection points. So I keep moving that down and we are not gaining any intersection points. So when our b value is less than -1, there are no solutions because they do not intersect. So what we're showing here is that a system that has a linear function and a quadratic function could have at most two solutions, it could have one solution, or it could have no solutions.